Hello everyone and welcome to this video of the course robotics. In this video we are going to work on a PC controlled robot, and we'll be controlling this robot into left and side using the commands given or signals given by PC via serial communication. In previous video we have seen the speed control of robotics, the speed control of robot and the angle control of robot using different techniques. And we know that the direction of the robot can go forward if the wheels move in the same direction, and the robot goes backward if both the wheels moves into the backward direction, and robot can take a left turn if the wheel is moving and the right is stop. The robot can take a right turn if the right is moving and the left is stop. So let's start with this, and we know that we're going to use 4 pins of Arduino into this, and going to control the two motors, the four terminals of the two motors, and we'll be using in this video is, and the next thing that we'll be using in this video is serial communication. So let's get started with that. So let's define the pin, and M11 equals to, I'm going to use pin number 6, and M12 equals to 9, and M21 equals to 10, and M22 equals to 11. Defining the pin mode of them. So pin mode of M11 is output, pin mode of M12 is also output, pin mode of M21 is also output, and pin mode of M22 is also output. And we'll also be using serial communication in this. So for serial communication, we'll be also defining the baud rate. So let's say that baud rate is serial dot begin. We're going to use a baud rate of 9600 bits per second. So we'll be putting it 9600 over here. And next thing, now our motto is to control the robot using the commands or the signals sent by PC. So let us say that if F is being sent, the robot should go forward. If from PCs we sent L, the robot should take a left turn. If from PC we are giving the signal R, it should take a right turn. And if we are giving the signal B from PC, it should take a back turn. And if we send S, it should stop. So let's say that we're going to program a robot on sort of 5 signals. So from PC we can provide 5 signals, and similarly it is also possible if we can control it from PC by giving it serial communication signals. We can also control the robot by using our Python script. So later on we'll also try to interface the same program using a Python script, and we'll try to provide the conditions to the robot in different conditions based on the image data sent by it. So as of now, let's define while serial dot available, and when some serial data is available, at that point we'll try to read data into character. So let's say char data equals to serial dot read, and now we'll compare the data. If data is equals to f, the robot should go forward, and if data is equal to b, it should go backward. If data value is l, it should go left, and if data is r, it should go right, and if the data sent is s, it should stop. So let's program with that. So we'll be writing if data is equals to s, for that we'll be writing stop code. For that we'll be making one terminal. For that we'll be making all the terminals low. So for that we'll be writing M11 as low, distal right M12 as also low. So in this case both the motors will have to stays stop and if both the motors are stopped, we can say that the robot is moving. So in this case also M21 will be low and M22 will also be low. Now let's talk about the next condition where the data is equal to F. So this condition is for forward direction of the robot. So now we have to write a code for forward direction of the robot. So let's say that for the forward direction of the robot, the code that we'll be using is taking both the motors in the same directions, high low high low. So that will take the motor in a forward direction. So let's program that. Digital write M11 comma low, digital write M12 comma high. So this is going to take our robot forward. If with the second wheel is also into the same direction, so we'll make M21 comma low and digital write M22 as well low. So let's say that this is the condition for taking the bot forward direction. And next, else if data is equals to R, in this case we want a robot to take a right turn. So for the robot to take a right turn, we'll make the right wheel, that is the first wheel, stop and the left wheel go low. And in the forward direction, this will be high instead of low. So I'll just make correct it. And now coming to the right direction, so we'll make first wheel moving and the second wheel stop. So for that we'll be writing digital right. So first wheel moving, it should be low and high. So M11 will be low and M12 will be high. Now the second wheel has to be stopped. So on the both the terminal of second wheel will be providing logic low. So for that we'll be writing digital right M21 comma low and digital right M22 comma low. And next, let's say now we use to program it for data is equals to L, that is for left. So in left case, the first wheel has to be stopped and the second wheel has to move on. So we'll be making the first wheel stop. For that we'll be writing digital right M11 comma low and digital right M12 comma low. And for making second wheel moving, we'll be making digital right M21 comma low and digital right M22 comma high. So this will be the command for the left one. And the last one, let's say that for backward direction, so for forward the direction was low high and low high. Similarly for backward it would be high low and high low. So let's define for backward part. So else if the condition would be data is equals to B, we are considering that the letters sent are in small case. So in this condition we'll make it distal right M11 comma high, distal right M12 comma low and distal right M21 comma high, distal right M22 comma low. So let's say that these are the conditions for which we are doing programming, and let's check the program again. Now let's save the program and compile the program. There seems to be some compilation error because of one extra packet, so I'm gonna delete it out and again compile it. So now that the program is compiled, let us select the port which is already selected. Now let's upload the program. And now that the program is uploaded, let's check controlling it whether it is working properly or not from serial monitor. So this was serial monitor and I have selected baud rate as 9600 bits per second, and let's send it F and check whether the wheels are going forward or not. So with the wheels part, it can be analyzed that wheels are going forward. If we write F to it, and if I want to stop it, I can write S to it now, and the wheels have stopped. If I want to take the wheels backward, I can send B, enter, and the wheels are going backward. And if I want to stop them, I can use S to stop them up. Let's say for taking a turn, I want to take it left, I should send L. So L will make one wheel moving and one will stop. If I want to stop it, I can send S. If I want to take a right turn, I can send R. And right will make another wheel moving and one stop. Again at any point of time I want to take left turn, I can send L. And then I can want to take backward, B, forward, F. And this is how multiple signals can be analyzed, and a robot can be easily controlled via serial communication from PC. And currently the serial communication is being done using the USB cable. So I hope the program would have been clear to you, and we don't know this program. Thank you for watching this video, and stay tuned for the coming videos in which we'll be designing Android controller board